Shots. Can't do anything about shots. What's the other thing that they hate? They prick their finger to get the blood out. Don't you hate that? Wouldn't it be easier if they could just, spray your hand and get the blood out that way? Wouldn't that be cool? Yeah. Now I like you guys, but I'm not going to bleed for you. Sorry. So what happened here? This is just ammonia window cleaner. Nothing special there. The special thing here is the paper. This is goldenrod paper. Now they used to sell this at the copy store. They've changed the dye that they use. I'm trying to talk them through changing it back. But what they used to use is turmeric. Some of you probably have turmeric at home on your spice rack. Most of the original indicators were flowers, leaves, roots, parts of plants that change color with acidity and basicity. So turmeric is a nice bright yellow color. They use it to make food nice yellow colored in Indian cooking and things. But under basic conditions, it turns bright blood red. Is it staying red though? No, it's starting to fade because the ammonia is evaporating. And so it's going to go back to orange. Now, if you can get some of the old-fashioned goldenrod paper, you can do fun things like write secret messages or draw pictures, and then as it evaporates, you can do it over and over again. It's a fun project to do if you work with little kids, or you can just spray it. That works too. Let's see. When I went to the forest this morning, I ordered multicolored flowers to make it pretty, but all they had was white. Chemistry can fix a lot of things. Let's see if we can make this more interesting. There you go. That's good. I'll let you guys figure that one out yourself. Wow. All right, now this next demonstration is going to use the dry ice again. Our first demonstration with the dry ice, the bubble, was that a chemical change or a physical change? Chemical. No, that was a physical change. We went from solid dry ice to solid carbon dioxide to gaseous carbon dioxide, but it was still carbon dioxide. This next one is going to be a chemical change. So I'm going to, in this graduate cylinder, I'm going to put, first I'm going to put a little bit of base, a little bit of sodium hydroxide. We're going to call it lye before. Probably put a little bit too much in actually. Yeah, it'll work eventually. The next thing I'm going to put in is a universal indicator. It's a little bit hard to see from up there, but it's called a universal indicator because unlike the goldenrod paper here that does one color change, it goes through a whole series of color changes. So based on the color, we can tell approximately how acidic or basic it is. Again, under neutral conditions, it's kind of this sort of greenish color. Under basic conditions, it turns really pretty purple. Now, when I add the dry ice, carbon dioxide reacts with water to make carbonic acid. That's why things like carbonated sodas are slightly, it's one of the reasons why they're slightly acidic, is because of the carbonic acid from the carbonation. Now what should happen is, in addition to being a nice cool chemistry looking demonstration, as that carbonic acid forms, it's going to neutralize the base, and so this should go from purple to blue to green to yellow. If we made it really, really acidic, it would actually go red, but it won't get quite that acidic. It's starting to go a little bit to the blue. Again, it's a little bit dark, it's a little bit harder to see. While this is going, you can actually do a version of this at home. Now, it won't have all the bubbles and everything. Yeah, we got blue going. If you can talk to your folks and find you a nice big head of red cabbage, because we all like to eat red cabbage. Blech. You don't have to eat the red cabbage. You don't have to cook the red cabbage. We got green going. But that purple color in the cabbage is also universal indicator. So you take a couple of leaves of red cabbage, tear them up in a plastic in a Ziploc bag, start green going. Add some water and mix it up and let it sit for about half an hour. When you take it out, you can use that purple juice to test things around the house, like lemon juice and baking soda and milk and things like that. Now, I always have to put a warning at this point. Never, ever, ever just randomly mix chemicals. You can kill yourself that way. You really can kill yourself. But if you're mixing things like pickle juice and cabbage juice and lemon juice and milk and baking soda, stuff that you would normally eat anyway, you're probably pretty safe. It should go a little bit more yellow than that. While we're waiting, we'll start another demonstration. So we're going to ask you to do some